सभी बता रहे होंगे।
Hello guys, are you able to hear me? Can someone confirm please? Okay.
Yes, sir, you're audible.
We'll start in a few minutes, maybe 2 or 3 minutes. Wait for other people to join.
बजे वाली 2:30 बजे वाली।
Okay guys, let us start with the session. So what were we doing in the previous class? Can someone give me a quick recap? We were talking about Python and I think we were on the topic of oops. And I think we concluded oops and then we were looking at some concepts which we had left behind like exception handling and then something about list, right? Do you guys recall? Did you guys try out the assignments that I shared for oops? There were a few questions where you were supposed to implement some classes and instances. Did anyone attempt those? If anyone has done that and would like to present, I would be happy to see what you have done. Maybe you can explain it and other guys can also see it. Especially if someone who has started Python in this course, who did not know Python earlier, and then if they have attempted the oops uh, assignment and they have implemented the questions that I shared. If anyone wants to volunteer, I'll be very happy to see. Otherwise, we can continue. Today, I'm planning to start with DSA. So today, I'm planning to have an introduction to DSA, and then maybe start with arrays. That's my plan for today. No one? Okay. Okay. Fine. Then we will start with our discussion for today. Let me just quickly open my terminal. 1 second. Did you guys follow everything in Python? Because I want to conclude the Python part now. So, is there anyone who feels that there is some concept in Python that you have not understood? If you want any further explanation for that, or I can cover that, or I can give you some reference. You can share it in the chat. Mohammed Saif is saying shallow copy and deep copy. Shallow copy, deep copy, I will cover in arrays. When we cover arrays, we will discuss Python list again. At that point, I will explain about shallow copy and deep copy. In fact, today itself, I will cover. Rahul is saying file handling. File handling will cover. I will note it down. We'll not cover it today. We'll cover it some other day. It's not file handling is not very important in terms of your DSA learning. It's important, but let me. Are you guys able to see my screen? File handling I've already written here, so I will show it. Okay, shallow copy, deep copy also I've written here. Slicing in list is done. Okay. Bitwise operators have not taught. Strings also we discussed. Marking it as done. Debugging, I did not show you IDE. Okay, I did not show you PyCharm. So PyCharm we will see when we start writing some code in DSA. At that point we will see. And the decorators, file handlers, generators also I did not teach you. Generators and iterators. Generators in Python. This I have not taught. So this also probably sometime later we will discuss. Okay, guys. So today let us start with our discussion about data structures and algorithms. We'll do an introduction. We'll talk about. Let me lay down what are the things we'll discuss today. Let me write it in a better way. Just give me 1 second. Guys, all of you are able to see the screen? Online guys, please respond. Is my screen visible clearly?
Yes.
Okay. So guys, have you heard about data structures and algorithms? Do you guys have any idea about what data structures could be? Anyone can get me started with what is your understanding of what data structures could be? or what is your intuition behind data structures and algorithms also? You must have heard the word very often, right? Data structures. So what is the idea that comes to your mind when you hear the word data structures? Or why are we first of all studying data structures? What is the importance of data structures? Why would we want to study? What is the motivation? Can someone tell me? To clear interviews. That's a good motivation. But as a programmer, as a software engineer, our intention is always to solve some real world problems. Correct? That's why we are learning programming. That's why we are learning data science. That's why we are learning AI. That's why we are learning anything to be able to solve some real world problems. When we're trying to solve some real world problems, we are always going to solve it. More often than not, we are going to solve it using some data. What is data? Can someone give me a layman definition of what data would be? Kanaya is saying better way to write a code which uses less memory in less time. Yes, that is good. Data organizing and sorting. That is a good definition for data structures, correct? Sorting, I don't know. Logics, improving way of thinking. That is also correct. Measure of storing variable efficiently. Shantanu is saying product-based companies. Okay. Kanhaiya is saying a better way to write a code which uses less memory. Sumit is saying DS and algo both different. DS for optimized code, algo to solve problem efficiently. Both the things sound similar only. Optimized code and to solve problem efficiently. What's the difference? Write a program with less space and less time. Data is information, collection of information, piece of data is collection of information. You can say that raw facts. Okay, this raw facts. And raw facts, when you process, then it becomes, you can say it is information. It's a very bookish definition. It's not, nobody's going to ever ask you that what is data and what is information. But for our understanding, when we have raw facts, you collect maybe information about marks that students have scored in exam, and then you do some processing on it, and so that it becomes information, right? So that is what we call as that is basically what we usually do to solve some real world problems. Usually we'll need some data or basically collection of raw facts, and when then we do some processing on that, and we do obtain some information from it, and that information might help us to solve some business problem, or to be able to solve some real world problem. So that is our motivation. Now, where does data structures come into picture? So if we are trying to solve some problems, and if we are working with data, it becomes very important for us to store data. How do we store data? It depends on what we want to do with the data, right? So you can say that it is a way to store and organize data. Again, these definitions are not very bookish. Okay, if you read some book, maybe you will get a better definition. But this is for a way for us to understand. So a way to store and organize data, okay, in order to solve some problem. So can you give me an example of a data structure? Like I'm saying a way to store and organize data, but in what way? Like I don't know. This definition sounds very vague. So is there an example of a data structure where we store or organize data in a particular way in order to solve some problem? Or what do you mean by storing and organizing data? How have you been doing it up till now? Someone is saying stack. Okay. Array. Okay. First in, last out, queue. Okay. So you guys are giving me some examples. So some examples you are telling me is first is array, and then someone is saying stack, then someone is saying queue. Okay. What else? Linked list. Okay. Database, we also store and organize. Okay. Graph, find trees, graphs, hash tables. Correct. So all of these are different data structures, or all of these store data in different ways. And we will first talk about array, because array is the most fundamental data structure. Whenever we start learning about data structures, we always talk about, first we talk about arrays. Okay. So we'll talk about that. Rahul Pandey is saying DP, dynamic programming. Dynamic programming is not a data structure. Okay. So what else about data structure? Okay, fine. Data structure, we have seen something. Okay, I think all of you understand. You have a high level intuition of what is a data structure. What about algorithms? What's an algorithm? What would you say is an algorithm? Efficient way to process. Okay. So we are going to learn three things in this data structures and algorithms. If I talk about it, majorly we are going to learn about three things. One is data structures. The second is algorithms, of course. And the third is measuring, evaluating, a way to evaluate. Good data structure and good algorithm. So first of all, what is the data structure? What is the algorithm? And what is the data structure? What is the algorithm? And then how do we write good algorithms? How do we choose good data structure? So that choice is also very important, right? So that's because someone wrote efficiently. So now what does efficient mean? I don't know at this point. Okay. So what is an algorithm? So someone is writing sequence of logical set of rules for programming. That is also correct. A sequence of steps, basically. Algorithm is a series of steps, or you can say series of steps. Okay. Now these steps to solve a problem, or we can say if we have some input and we have some algorithm and we are able to reach the output. Okay. Now what are some caveats here? When we say steps, series of steps, we always say that these series of steps should be finite. Means there should be 5 steps or 10 steps or maybe 100 steps or 1000 steps, but there cannot be infinite number of steps. Okay. And when we say solve a problem, okay, series of steps should be finite and they should be unambiguous. What is the meaning of unambiguous? Means there should be no confusion as to what we are supposed to do. Every step should very clearly define what is the next step, what next step is going to be. There should be no argument between me and you as to what the algorithm says. The algorithm should be unambiguous. Okay. And in order to solve a problem, but obviously when we say solve a problem, it should be that we are solving the problem correctly. That means the algorithm should give the correct result. Okay. And when we say solve a problem for a given input, so this should be for all valid inputs. Okay. So this is also important. When we write algorithm or when we propose a solution, it should not just work for some inputs. It should work for all valid inputs. Should always work. So if you remember last time in the last class, we were doing some questions where I was asking you to write some a function to get the sum of alternate numbers and get number of consecutive pairs and those type of things. And some of you were giving me code saying that, sir, this code works on this input. And I was saying that, no, this is not correct. Because when you write a code, when you're writing a function, it is supposed to work for all possible sets of inputs or all possible sets of valid inputs. Right? Do you guys remember? All of you guys remember? Okay. So that is the definition of an algorithm. Is everyone with me so far? Anyone is having any confusion up till here? Okay, so now that we have seen some definition of data structure and algorithm, can we do some example in order to solidify what we have learned? So can you give me example of a data structure? So I will take example of a data structure. Example. Okay, say for example, or before doing this, let us okay, fine, let us take, say for example, that I want to store marks of 10 students. Okay, so how do you propose we can store marks of 10 students, given your knowledge of Python that you have learned so far? A very naive way to do it is that you would say that, let me store like this. Let me say that I will have marks 1 is equal to 100, marks 2 is equal to 150, marks 3 is equal to 145, marks 4 is equal to 120, and so on, so on. Marks 10 is equal to 150. Okay, suppose I'm storing marks of 10 students like this. Is this a good way to store, where I'm storing one value in a one variable? Is this an acceptable way of doing it? What do you guys think? Or should I be doing it in a better way? Or should I instead do it like this? So when I present this to you, and if I'm asking you that if this is a good way to do it, you should be asking me that whether this is good or not, depends on what I want to do with these marks. Okay, if I want to store marks of 10 students, what do I intend to do with these marks? And depending on that, I will choose a data structure. Does that make sense, guys? Okay, so one proposed way would be that you can say that, sir, you can actually create a Python list out of it, and you can call it maybe marks like this, and you can store it in a list, and you can say 100, 150, 145, 120, like that, and you can store 150. So what is the benefit of storing marks like this? Can someone tell me?
We do not have to create multiple variables.
Okay, if we create multiple variables, so what?
It will take more memory.
It will not take more memory, because you are storing 10 integers, 10 marks.
Sir,
So if every marks is taking, say for example, 4 bytes, so here also it will take that much, here also it will take that much. Why will this take more memory and this will take less memory?
Easy to access in the second way.
Sorry?
Easy to access in the second way.
Easy to access in?
The second way. Which
इंडेक्स की मदद से एक्सेस कर पाएंगे.
इंडेक्स की मदद से एक्सेस कर पाएंगे, यहाँ भी तो मैं एक्सेस कर सकते हैं ना, क्या प्रॉब्लम? सही बात है, इंडेक्स की वजह से कर पाएंगे. तीसरे स्टूडेंट का चाहिए तो आप मार्क्स 2 कर लोगे, लास्ट का चाहिए तो मार्क्स -1 कर लोगे, तो यहाँ भी तो कर लेंगे ना, क्या प्रॉब्लम है?
तो स्पेस कम लेगा मे बी.
स्पेस कम क्यों लेगा? चलिए इसके बारे में आप सोचना, ठीक है, फूड फॉर थॉट आपके लिए.
रैंकिंग कर सकते हैं.
रैंकिंग कर सकते हैं, हाँ ठीक है. इसको आप सॉर्ट कर सकते हैं अच्छे तरीके से. बेसिकली एक जगह पे ऑर्गेनाइज्ड है, मैं बहुत ढीले ढाले भाषा में बोलूँ तो एक जगह पे ऑर्गेनाइज्ड है सारा मार्क्स. आपको 100 वेरिएबल से ट्रैक करने की जरूरत नहीं है. सपोज आपको एक नया वेरिएबल यहाँ ऐड करना पड़ जाए, है ना, सपोज यहाँ पे अगर आपको एक वेरिएबल ऐड करना पड़ जाए या कोई वेरिएबल आपको हटाना पड़ जाए, तो आप इजीली डायनामिकली आप उसको एक मेमोरी स्टोरेज में आपने स्टोर किया हुआ, एक जगह पे स्टोर किया हुआ, तो आप इजीली उसको एक्सेस कर सकते हो. ठीक है, तो ये एक तरीका हुआ डेटा को स्टोर करने का, जिसको हम लोग बोलते हैं एरे. ठीक है, अब इसको मैं बोल रहा हूँ डेटा स्ट्रक्चर, यानी एक तरीका हुआ. दिस इज अ वे टू स्टोर डेटा इन अ सर्टेन वे. व्हाट इज दैट वे? वी हैव नॉट डिस्कस दैट, सो वील डिस्कस दैट व्हेन वी गेट टू अरे. that how array is a data structure or how actually data is stored. Right now I have just drawn one dabba like this, and I have written like 100, 150, like this I have written. But what does this actually mean? Right? So this we will discuss. Alternatively, I could have also stored it in a different way, where I could have said that this is 100, and then the next data point is how much? Maybe this is 150, and the next data point is 100, and the next
Pointer.
data point is 150, and the next data point is 120, and the next data point is 80. This is also another way of storing the same data. Now you will say, what is the difference between this and what is the difference between this?
सर ये एड्रेस स्टोर रखता है
कहाँ पे?
सर मेमोरी में एड्रेस और कॉन्टिन्यूअस एलोकेशन होता है जब भी एरे बनाएंगे तो
Correct. So हम लोग जब array बनाते हैं, when we talk about array, just giving you an example, okay? We are not talking in detail about array. We'll do that little bit later. But suppose we are creating an array. Okay. So what happens? We take some memory location and we say that I'm storing 150 here, storing 100 here, I'm storing 120 here, storing 80 here, and I'm storing 45 here, and I'm storing 180 here. Okay. So there is a fixed, we are assigning some memory location. So this is one memory location, or we'll say this is one memory cell. Okay. How much this cell is, that is not very important, but we have a address to this cell. Suppose इसका जो address है, जैसे घर में हम लोग we take flats, so every flat has a number 301, 302, B block, C block, like that. So suppose the address is 200, okay, and this address is 2004, and this address is 2008, and this address is 2012, and this address is 2016, and this address is 2020. So what is it? We have stored marks of 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5. We have stored marks of 6 students, and 6 students are in 6 adjacent memory cells. एक के बगल में एक. Okay, so this is what we call as, this is, don't focus on what is an array. What I'm trying to show you is that this is one specific way of storing data. There can be other way also. Okay, and every way has its own peculiarities. It will have its own advantages, it will have its own disadvantages, it will have its own applications, it will have situations where this will perform very well, there will be situations where this will not perform very well. So depending on what I want to do, that's why I asked you this question, that I want to store marks of 10 students. Is this a good way? And I said, whether this is a good way or not depends on what I want to do. Unless I tell you what I want to do, I cannot say whether this is a good way or this is not a good way. So I'm just giving you option that there are two possible ways. I mean, there are many possible ways, but right now we are discussing two ways. One is called as array, and the second is something that I have drawn here with arrows that I will get to. Okay, so I'm just giving you a brief high level understanding of array so that you understand what data structure means. We are not discussing array right now. Okay, we are only discussing what is a data structure. So this is a structure. This is a data structure of how data is stored. Okay, so little bit I will also talk about memory. Just remind me that I want to talk about memory and low level architecture. We'll talk about this a little bit, but before that, this is array. Okay, so this we say this is stored, we'll say, in contiguous way. Contiguous is a word that you should keep in mind. You will hear this word very often. What does contiguous mean? Sequential, one after the other, right? So if this is 2000, this will be 2004, this will be 2008, this will be 2012, this will be 2016, this will be 2020. So there is a gap of 4, which means each cell here is of 4 units, whatever that 4 is. Actually, that is 4 bytes, but don't worry about bytes. Just think of this as bookshelves, okay, which can contain 1 book or which can contain 4 books, equal number of books. Okay, so all of these cells can contain equal number of information. So each information is taking each data point 150, 100, 200, 120, 80. All of them are taking 4 units. Those 4 units are 4 bytes, but that byte part is not important. Just keep in mind that they are equal. So here we are keeping in contiguous way. Okay, contiguous memory. What is the benefit? What is the benefit of putting this in contiguous way? Some of you said, mentioned that some time back. What is the benefit of putting it in contiguous way? That we can easily access it using index. One person said this, right? We can easily access it using index. In what? So that is very good. Whenever we want to access it, we will be able to access it very easily. Very good. What can be a demerit of this?
सर सर इसमें मीन्स इसकी वैल्यू को चेंज किया जा सकता है
वैल्यू को चेंज किया जा सकता है, ठीक है. व्हेन वी से इजीली एक्सेस इट, वी कैन आल्सो म्यूटेट इट. फाइन. ये 120 को 150 करना है, कर देंगे, कोई प्रॉब्लम. वेरी गुड, दैट इज ओके. व्हाट एल्स? Someone is saying improves cache performance. Improves cache performance. इसका क्या मतलब हुआ? हाई फाई वर्ड्स यूज कर रहे हैं. कैश क्या होता है? कैश क्या होता है? व्हाट इज कैश?
सर कैश इज लाइक सर मतलब कोई ऐसे वेरिएबल को जो फ्रिक्वेंटली यूज कर रहे हैं कैश में स्टोर हो जाता है ताकि उसे जब दोबारा एक्सेस किया जाए फास्टली रिट्रीव हो सके.
ठीक है. तो जो हमने डेटा स्ट्रक्चर चूज किया है, द डेटा स्ट्रक्चर दैट वी हैव चोजन, व्हाट दैट हैज टू डू विद कैश? What you are saying is correct, absolutely, it is very good, but how is this related to cache?
सर एक्चुअली सर जैसे इसके मेमोरी एड्रेस है 2000. अगर मुझे इंडेक्स वाइज अगर मुझे एक्सेस करना है इसके फोर्थ एलिमेंट को या फिफ्थ एलिमेंट को, तो मुझे एक ही एड्रेस से एसोसिएट करके उसके नेक्स्ट वाले को एक्सेस करना आसान हो जाता है.
ठीक है, चलो. Vansh has written something very nice, that we will need that much contiguous space available in the memory. This is very good. Okay, that much contiguous memory should be available. Suppose 5 friends are going to watch a movie and all those 5 friends want to sit side by side, then contiguously 5 seats should be available in the memory in the cinema hall, right? 5 seats can be available, but if they are available in a scattered way, then we will not be able to sit. Similarly here, if I am saying that I want to store marks of 6 students and it has to be stored in a contiguous way, then that contiguous memory block should be available. Okay, so this becomes a positive point, this becomes a negative point. Okay, if you drag upon this concept only of contiguous memory should be available, because of the nature of, because it is contiguous, that's why we are having one advantage, that we are able to access fast. By the way, you did not give me an explanation of why it is easily accessible using index. Index is there, so how can we easily access it? If index was not there, then it is very difficult to access. Why? Who said easy access using index? Ramesh is asking if it does it store in RAM memory. Yes, it stores in RAM memory. RAM memory also we'll talk about.
Sir, one more question. If we delete any one of the index, any location something, so the address will be also interchanging, or will it be the same?
Very good question. If we want to, because it is contiguous, if it is contiguous, then you think about this way, that there are five friends. Okay, we will take a little time to talk about arrays, okay, because array is a fundamental thing. So we will go a little bit slow. Once you understand array properly, and then remaining time we will increase the speed a little bit later. So just imagine that there are 4 people or 5 or 6 people, okay, and all of them want to sit side by side, and the condition is that they always want to sit side by side. Okay, so if one person wants to leave, he's saying that one person wants to leave, then what happens? What should happen? Because remember, all of them should be contiguous. So if this person wants to leave, then what will happen? This is person 1, this is person 2, this is person 3, this is person 4, this is person 5, and this is person 6. So if this person leaves, then this becomes blank. So is that acceptable? No, because it has to be contiguous. So then this person will come sit here, this person will come sit here, and this person will come sit here. Mustafa is saying his slot will be empty. But if the slot is empty, then data is not contiguous. Keep in mind that we have to be contiguous. So every person will have to shift. Imagine that this, so if this person is leaving, person number 3 is leaving, then 3 person have to shift. 4 has to shift here, 5 has to shift here, and 6 has to shift here. Correct, no? So 1 person has moved. Because of that, 3 person have to change their seats. It's not a very good system. Imagine that it takes 1 minute for every person to shift. So if this person has to go, 1 person decided to go, because of that 3 person had to shift. So it took me 3 minutes to complete that operation. Imagine if first person wants to leave. Imagine if first person wants to leave. Then what will happen? 2 will have to come here, this person will have to come here, and then this person will have to come here, and this person will have to come here, and this person will have to come here.
But
So
sir,
6
they are
minutes
in
it will take.
contiguous, right?
Sorry?
Already like. Sir, if the first person is leaving, then the other is in contiguous, right?
Very good question. If first person
They are
leaves,
all together, right?
if first person leaves, very good. First person leaves, then these are still in contiguous. Correct, no?
Sir, there is a problem of means if that
So in this
slot-
example, what you're saying makes sense, but in computer language, it will not work. Computer language, everyone will have to shift, actually.
Okay.
But very good observation. But in computer, if this happens, then this memory will be permanently lost because of the way memory allocators work in Python and C. But your observation is correct. I'm sorry, what you said is correct. In this cinema wala example, what you're saying is correct.
If a second person has leave it, then it is n minus 2 operations you have to do for shifting the set.
Absolutely correct. Correct. Absolutely correct. So if these are n people are there, then if 1 person moves, then at max, worst case, n people have to move. Sometimes n minus 1 people have to move, sometimes n minus 2 people have to move, but at max, worst case, n people have to move. So whenever we are learning about data structure and whenever we are trying to evaluate what we are doing, is it good, is it not good, we always talk about worst case, by the way. Okay. So by the way, if 1 person decides to move, then n people have to change their seats, which is bad. Do you agree that this is bad? Did you guys agree? Did you guys understand the example that I'm giving? Guys, I cannot see anyone writing anything in the chat.
Yes.
Okay. So this can be a disadvantage that, and similarly, if you want to insert something, if I want to insert something, okay, suppose there is 100, there is 150, there is 200, there is 50, and there is 80, and I want to insert something here. Suppose in this position, I want to insert 120. So if 120 will go here, then 200 will come here, and 50 will come here, and 80 will come here.
Similarly for delete also, right? It takes the same number of.
Delete also, insert also. Correct. Now this insertion can be a problem also, because if 80 has to move here, then that space has to be there. If someone else is sitting in this seat, then 80 cannot adjust. So high level, what we are understanding is insertion and deletion can be inefficient. This is also one negative point. But easy accessing it using index. So someone said easy access using index. So no, you did not answer me why it is easily accessed. It is easily accessible because if you know the first address, if you know this address, if you know this 2000, then very easily, if I ask you that if there are 6 elements, what is the 4th element or what is the 5th element, you can very easily tell me. Pavan is saying inefficient insertion and deletion. Correct. Manas is asking, so with sorting, it will not be just n as worst case scenario. Sorting, we will talk about. Sorting is not what we are. Sorting is, it will not be n. Okay, it will be a little bit different. Okay, so so I'm trying to answer this part. If you are following me, someone said easily accessing it using index. How it is easily accessible using index, and what does easily mean? Easily means how easy. Okay, so easily accessible using index because suppose if we take this example, okay, suppose this is 150, this is 200, this is 500, this is 600, and this is 120. Okay, and this memory location is 0, this is 1, this is 2, this is 3, this is 4, and this memory location is suppose 2000, this is 2004, this is 2008, and this is 2012, and this is 2016. Okay, if you know the starting memory address, and starting memory address is very important, that's why in the cinema hall example I was emphasizing that starting we cannot get rid of easily. Okay, if the starting is 2000, okay, and if I'm asking you what is the fourth element, and if you know one more thing you have to know, and in I told you that each box has to be of the same size of cell is 4. Okay, this size is of equal size. Did I tell you, do you guys remember I told you some time back that each block has to be of the same size, and that is how it is contiguous also, no, because this is 2000, then this is 4, this is 8, this is 12, this is 16, so there is constant gap. That's why it is contiguous. If instead of 2012 this was 2020, then this would not have been contiguous. So when I say contiguous, it means the size of the cell is equal. It also means that every element is of the same type, but we'll get to that little bit later. Okay, size of the cell. So if I'm asking you address value of the third cell, if I want to access this, then it is very obvious that it will be 2000 plus what is the size of each cell? 4 multiplied by 3. So this will be 2012. So easily we can get the address of the third element if we want to access it like this. Okay, so why it is fast? It is fast because, and pay attention to this, what I'm going to say here. It is fast because if there were 4 elements in this, okay, by the way, this calculation, what I'm doing here, this calculation, what is this calculation? This is a simple multiplication and addition. So this happens in constant time. What is the meaning of constant time? Constant time means that here there were 4 elements or 5 elements in the array, okay, and I wanted to access the third element. So it took me some time here, whatever time it was taken by the CPU to calculate this. Okay, if instead of 4, there were 400 elements, then also it would have taken the same time. Do you guys agree? If instead of 4000 there were 4 million elements, then also this calculation would have been the same. I mean, the time taken would have been the same, right? That's why we say that it is easily accessible using index. It is easily accessible using index. Why? Because it is using arithmetic. It's called using pointer arithmetic. Or that is not important right now. Ignore that. Okay, just say that we can easily access it using index. So we learned 2 positive points and 2 negative points. Now I told you that again, choice of data structure, whether we are using, which part is not clear, Anubhav?
Sir, if there are millions of records, then they may take a little more time, right?
थोड़ा जोर से
So,
बोलिए. Are you saying that if it so
yeah,
so
if there are millions of records, then it may take a little more time, no?
why?
No, I presume that the calculation can be a little heavy to
Okay,
get. Yeah.
okay. See, fair question. Fair question. We will talk about that. when we talk about you're saying that if instead of this 4, if it was 2000 plus 4 million into 3, then this will take more time, correct? For a CPU, this is just one calculation. Okay. For CPU, this is just one calculation. This is one primitive operation for one CPU. So amount of time taken for this, amount of time taken for this, versus if this was 4 billion also, we'll assume it to be the same. If it is not clear, just park this idea for some time. Why I am saying that this is constant time?
It is more about the complexity, right? Complexity of the calculation. I got it.
Sumit is also saying why arithmetic calculation is constant. For now, just assume it. I will explain it when we get to time complexity. Okay, but it is constant time. I'll give you one example of when it is not constant, then you will understand. Okay, so this is one data structure which we saw at a high level, which is array. Which is if we had to store data of 6 students, this is how. This is one proposal of this is one way we can store. If we store it this way, then there are some advantages where we can easily access it using index. Okay, and we are improving cache performance, whatever that cache performance means. Don't worry too much about this one. Okay, but because it is, and this advantage is because it is contiguous. Okay, and because it is contiguous, for the same reason there is also some disadvantage, which is that contiguous memory should be available in order to store it, and insertion and deletion can be inefficient. Correct? So there are some positive points, there are some negative points. This is one proposal. Now can you tell me where this can be used and where this should not be used? Where this should be used, where this should not be used? Very simple answer, that whenever we want to access the data or we want to just read the data, right, where we just want to read the data, there it is a very good data structure. It is a very good data structure. But if we are looking for some data where some structure where we constantly want to add things and remove things, then this is not a very good data structure. Are you guys following? In contrast to this, because we just learned one data structure, let us learn one more data structure, and then you can compare it, and then you will understand a few more things. Okay, so I want to propose one more alternate to the same problem. I want to store marks of 6 students. Okay, but I want to store it in a slightly different way. Okay, so let me take the same array here. Bring it here, and I'm saying that I want to, what was the disadvantage of arrays? That we needed contiguous memory. I'm saying that I will not store it in a contiguous way. I will store it like this. I will store it, I will say this is 150 and this is 200 and this is 500 and this is 600 and this is 120. Okay, suppose I said that I want to store data like this and I don't want it in a contiguous way. I will store it however I want. So if this is 2000, this is 3000, this is 2050, this is 3100 and this is 5200. So randomly I'm storing in a scattered way. Okay, randomly I'm storing it in a scattered way. This is non-contiguous way. So this, so you will ask, if you are storing it in a non-contiguous way, then what is the benefit? Because how are you going to access it? How will you know that first person is 150, second person is 200? How are we going to find that out? So I will say that it is like a chain. I will make a chain kind of a thing where I will store this 150. Okay, and I will also store the address of where is the next element. So first element is 150, the second element is 200. I will store the value here, and I will say 3000 is here, which means 3000 pe next data we will find. Okay, so 3000 pe will go and we'll come here to 3000. Here we'll see the value is 200, and I want to go to the next value, so I will say 200 ke side mein I will also store the address of the next element, which is 2050. Okay, and at 2050 I will come here and I will find the next element, which is 500, and once I have found 500, I will also store the address of the next element, which is 3100, and I will go to 3100. I'll find the next element, and here I will also store the address of the next element, which is 5200, and after 5200 there is nothing, so I will just store a none here. Okay, so this becomes that 150 has the address of 200, 200 has the address of 500, 500 has the address of 600, 600 has the address of 120, and 120 has the address of none, which means this is finishing. So if I want to represent it in another way, I can write it like this. I can say 150, and I will draw this arrow here, and this is 200, and I will draw one more arrow here, and this is 500, and this is arrow here, which is 600, and I'll draw one arrow here, which is 120. This is only what I draw. I was drawing earlier here like this. Okay, so this is also a list. This is also a list, but this is called as a linked list. Linked list is also a data structure. Why it is a data structure? Same data, but we are organizing it in a different way. What was the definition of data structure that we saw? A way to organize and store data in order to solve a certain problem. Okay, here also we are organizing and we are storing the data, but it is slightly different from the earlier example that I gave you, which we were calling it as array. Okay, so what are the points that you can tell me about this data structure? What will be the advantages? What will be the disadvantages? So in array, you were telling me that we can access things faster. Okay, what about here? Can you access it faster? If you talk about access, is it fast, or it will be fast or faster or slower compared to arrays, and why? Can someone give me a reason? It will be slower. It will be slower because if you want to reach this 600, earlier what was there? Because it was contiguous memory, and because we knew the starting address, so we could just calculate saying 2000, saying starting address plus number of bytes multiplied by number of cells, and we were getting the address of the desired cell. But here there is no such thing. So you have to start with 150. 150 you will start with 150. 150 will tell you the address of 200. 200 will tell you the address of 500. 500 will only tell you the address of 600. So in order to reach 600, you have to reach 500. In order to reach 500, you have to reach 200. In order to reach 200, you have to reach 150. Okay. So in order to reach the third element, you had to do 3 jumps. 3 times you had to jump. Okay. 150 का एड्रेस पढ़ो, 150 का एड्रेस पे जाओ, 150 पढ़ो, 150 आपको 200 का एड्रेस बताएगा, 200 का एड्रेस पे जाओ, उससे फिर मेमोरी से लोड करो, फिर 500 पे जाओ, फिर वहां एड्रेस पढ़ो, फिर मेमोरी में लोड करो, फिर जाओ 6. So you have to do a lot of work, and that work is proportional to which element you are trying to access. If you are trying to access the first element, then there is no problem only. But if you are trying to access the fourth element, then you have to do 4 operations. If you are trying to access 400th element, then you have to do 400 operations. If you want to do 4 millionth element, then you have to do 4 million operations. So accessing an element depends on which element you are trying to access. That was not the case with arrays. Are you guys able to compare?
Give me one
Guys,
example, sir. Give me
Huh?
one examples. Can you give me one examples to compare?
I'm just
Small
giving you
examples.
example only that in
Yeah.
array, it was 150, 200, 120, and 600. And here it is 150, 200, 120, and 600. Because of the way they are stored in the memory, I'm saying that this is data structure 1 and this is data structure 2. Okay, this is called as array, this is called as linked list. Okay, and I explained what is the difference between the two. In array we are storing everything in a contiguous way. In linked list we are not storing in a contiguous way. Every element is having the address of the next element. Okay, so if we are talking about accessing element in array, it was very easy, because if this is in 2000, then I know this will be in 2004, and I know this will be in 2008, and I know this will be in 2012. But here, so if we know 2000 and if we know that every element is taking 4 bytes, then very easily we can reach any other element. So accessing was fast. In linked list that is not the case. I'm asking you to think whether this is going to be, accessing is going to be fast or slow. So I am saying that this is going to be slow. Why it is going to be slow? Because if you have to reach 600 element, then you have to always start with 150. 150 will tell you 200, 200 will tell you 120, 120 will tell you 600. So you have to make 3 jumps. If you want to access third element, you have to do 3 jumps or 3 operations. Here you have to do 1 operation. Whether the list is having 4 elements or 400 elements or 4 million elements, in order to access any element, it is taking you only 1 operation. There is only 1 calculation you have to do. But here, if you have to go to third element, 3 element is taking 3 steps. If suppose 300 elements were there, then it will take you 300 steps. And if there are 3 million elements, then it will take you 3 million steps. Are you observing what is happening here?
Yes, yes. Actually, in the array, it can be done within single shot through the
With a
calculation.
single?
Within the single application, single calculation.
So 1 calculation you have to do.
Yeah.
But in
Correct.
linked list, that is not the case. So accessing an element is slow.
Right. But at the same time, for in linked list, or for each element has the overburdening the memory, right? But
Correct.
it has maintained address of the next node
Correct.
as well. Then.
Correct. So
Yes.
there is memory overload. Correct.
Memory burdening. So,
You can say there is memory overhead.
overhead. Yes.
Okay, so this is a negative point. This is also a negative point. What about a positive point? Is there someone is saying, then why are we, what is the benefit of linked list? There must be some benefit of linked list, that's why it is existing, correct? So what can be the benefit compared to array? What was the disadvantages of array? That contiguous memory should be available. Okay, but here, is there any such thing? Do we need contiguous memory to be available? Because it is stored in a scattered way, so is there a need? Data is stored in a data is stored in scattered way. No contiguous memory, no contiguous block of memory needed. So this is one positive point. Why? Because imagine earlier I gave you example of five friends. They want to go to watch a movie. They are all want to sit side by side, right? Here, all 5 can sit in a scattered way, but the person 1 knows where person 2 is sitting, person 2 knows where person 3 is sitting, person 3 knows where person 4 is sitting. So you want to go to person 4, you have to go through first 3 people. But if they're all sitting together, then if you know where the first person is sitting, relative to that, you can calculate where the fourth person will be there. So you don't have to go through 1, 2, 3. Correct? And here, there is one more thing that someone said here, that if we want to access or delete something, insertion or deletion is efficient if reference node is known. Okay, what does it mean? That insertion and deletion is efficient in a link, in an array. We saw that insertion and deletion was problematic because if one element you are removing, every other person has to move. It becomes problematic. In a linked list, that is not the case. So if you are having a linked list like this, okay, you're having 150, you're having 200, if you're having 60, and if you're having 80. Okay, and if I want to remove this 200, if I want to remove this 200 from here, but how do we know the reference node? Wait till that. Okay, we'll discuss in detail when we are talking about linked list. Okay, but suppose if you are standing here, suppose if you are here, if you know this 200, and if you want to remove it, reference node means where you just wait for a second. Okay, so I'm saying that suppose this is a linked list. Okay, and if the same thing was an array, suppose it was 150 and this was 200 and this was 60 and this was 80, and I asked you to remove this 200, then what did I say? I said that this will be problematic. Why? Because this 60 has to move here and this 80 has to move here. So one element has to be removed. Remaining all elements have to adjust. Correct? Do you guys follow? Guys, are you following? I feel that your energy has gone down from the beginning
No,
when
it's
we
not
started. If you guys are quiet, then I get doubtful that whether what I'm saying is not understood. Okay, so in an array, when we had to remove an element, it was problematic. Okay, but in a linked list, suppose if we are standing here, if we know this 200 and if we want to remove this 200, so why it was problematic? Because if there are 4 elements and I wanted to remove this element, then 2 elements have to be shifted. If instead of this there were more elements in this array, if there were more elements here like this, there were more elements, then those also needed to be shifted. Okay, so deleting here depends on the length of the list. If the length of the list is more, then it will take more time. If the length of the list is less, then it will take less time. So it is problematic. Okay, later on you will see that this we will call it as a linear time operation, because if there are 5 elements, then it is taking 5 steps. If there are 500, it is taking 500 steps. So it is problematic. In a linked list, however, if we want to delete this cell, if we want to remove this cell, what can we do? Suppose this is one person, this is another person, and this is one person, and this is another person. This person knows the address of this person, 1 knows the address of 2, 2 knows the address of 3, and 3 knows the address of 4. And I just want to remove the second person from here. So what can I do? I can say, give the address of the third person to the first person. I can tell 1 where 3 is sitting. Okay, and my job is done. 3 knows 4, 4 knows 5, 5 knows 6. There is no problem. So if here there was one more element, and then here there was one more element, and here there was one more element, even if there were 500 elements, it is not going to take much time because only one operation I have to do here. So is insertion or deletion good? Here, if I want to insert something, suppose after 60, I want to insert a new person. Okay, suppose there is 100. I want to insert. Okay, so I'll just say that
Change
60,
address. Yeah.
60 should know 100 and 100 should know 80. And this person is now added in the chain. Now, after 80, how many elements are there? I don't care. Why? Because this is not contiguous.
It's not getting disturbed. Yeah.
It is not getting disturbed. Did you guys understand? Did you guys understand? See, here my idea is not to teach you array or linked list. My idea is to teach you what is a data structure. Okay, so when we say, when we started our discussion and I said that data structure, okay, I will come to here later, but now I talked about array and linked list. So I want to ask you that where would ideally a linked list be better and where would a array be better?
The insertion and deletion case is better with a linked list.
Can you give me an example? That I have already told you that insertion will be better and all that. Where would that, because when I started the discussion of data structure, I told you
List and linked list both are same, right?
list and linked list are same. No, list I have not discussed till now.
Is there difference or same?
They're different. We are talking about array and linked list. List we have not even discussed.
But in Python, array is not there, na?
Array, we will talk about that. I'm asking you what I have discussed right now. We will, when we get to list and Python, that time we will discuss that. List is a different thing. List is a type of array. Okay, but that is a different discussion. I'm asking you array and linked list. Can you tell me application of where you will use an array, where you will use a linked list, depending on your knowledge of data structure, depending on your knowledge of the pros and cons of array, where would a array be used, where would a linked list be used? So you can say, if for faster access array is there, of course, that I've told you that this is
the faster access.
Faster access. Okay, and this is for faster
insertion or deletion.
Now someone asked me that I said here insertion deletion is efficient if the reference node is known. Correct, no? Which means that if I want to delete this 200, first I have to reach this 200. In order to reach this 200, I have to make that many jumps. Correct? So in that case, it is not very efficient compared to array. So this part, just keep in mind, we will discuss this when we talk about linked list in detail. But this is the important thing. Whoever noticed it, you good that you are paying attention. Okay. So if I talk about array, simple array, if you want to access, can you give me a real world example or think about it? Suppose when you're typing, okay, suppose when you're typing, you are saying, writing something. Okay. And if you imagine it to be like a sequential arrangement of things, okay, and you later on you made a spelling mistake. You made a spelling mistake and you want to put your cursor here and you want to add something or you want to delete something. If you are able to put your cursor here and you want to add or delete something, which one will be better, array or linked list?
Array.
No, linked
How
list.
array?
Linked list.
Linked list will be
Directly
better.
to go to the point.
Because you can easily do backspace or you can easily insert something.
But if we know the reference node, right? We don't know the.
Yes, if we know the reference.
So without reference, how can we make it?
If you know the reference, then in array, how much time it will take?
Yeah, deletion. Yeah, correct. It will be also the problem that is.
Okay, this is one example. Array is whenever you want faster access. Suppose you have stored a lot of information about your student marks and you just want to see what is the marks of 10th student, what is the marks of 50th student. You want to retrieve data, then in that case, array is very, very fast. Okay, someone talked about cache performance. Okay, cache we will talk about when we discuss in detail about array and linked list. Okay, so guys, did you get a understanding of what is data structure and how every data structure will have some positive points, some negative points, and depending on that, that data structure can be suited for some application, may not be suited for some other application. Is this part clear, guys? I know there might be some confusion, some things in your mind, but high level, if you have understood, then that our problem is solved. Our intention is completed.
Doesn't linked list have the index value, right, sir? Only
No,
array has
linked list
index
does not
value.
have any index. Similarly, there can be other data structures. Okay. Similarly, there can be other data structures also. For example, I'll give you some more example. That suppose you're trying to represent, okay, you're trying to represent some information about your home. Okay. So suppose you can say that this is my home. Okay. From my home, I can go to shop. Okay. And from shop, I can go to my tuition. And from my home, I can also go to my school. Okay. And from my school, I can also go to my playground.
Yes, of course.
Okay. And there is some relationship here. For example, from home, I can go to school. So some map kind of a structure. Okay. From home, I can go to school. From school also, I can go to home. Okay. From home, I can go to tuition also. Okay. From tuition also, I can go to home. But from shop, I can only go to tuition. And from tuition, I can only go to playground. And from playground, I cannot go to school. Okay. Suppose this is the information that I have to store. Okay. So how will you store this data? One way can be that you can say that, sir, I will store this data in the form of a I will store this data in the form of a list of tuples. Okay. From where we can go where. Okay. I can store it like that. So I can say from home, I can go to shop. So source and destination, I can store like this. From home, I can go to shop. From shop, I can go to tuition. Okay. From home, I can also go to school. Okay. From home, I can go to shop. From home, I can go to tuition. From home, I can go to school. From shop, I can go to tuition. From tuition, I can go to play. Okay. And from tuition, I can also go home. I can say that, sir, I can store it like this. This is one way of storing. This is one way of storing. Someone can say that I want to store it in a slightly different way. I want to store it as a dictionary. Okay. Dictionary is a concept. Dictionary is in Python, but the general concept for that is hash map. Again, we will learn about hash map a little bit later. Okay. But you can say that I can store it like this. I can say that I will have home as a key and I will make a list of all the places that I can reach from home. So from home, I can go to shop, tuition, and school. So I can make it like this: shop, tuition, and school. Comma. I can make one key called shop. And from shop, where can I go? Shop, I can go to only tuition. So I can go to only tuition. Okay. The third place is school. So from school, where can I go? I can only go to home.
Tuition also.
School, I can go to home. Home also, from home I can go to school. From school, I can go to home. Like that, I can create. Okay. Similarly, from tuition, I can go to home and playground. From tuition, I can go to home and playground. I can store it like this also. Okay. You can say that this is data structure 1 and this is data structure 2. Now, whether DS1 is better or DS2 is better,
So on what
both of them are storing the same information. Do you agree?
Yeah, but on what basis we need to say it's better? Is it time or in space?
Again, I answered this question many times. Depends on what you want to do. What you want to do.
DS2 is better.
Sorry?
DS2 is better.
Why?
Because if we want to make it any one element, right? We can look at all the relevant things.
Why list is better?
One
Because from
key
DS1
and
you can convert it to DS2. From DS2 you can convert it to DS1.
correct,
If
but
I
key
ask
and
you,
value pair.
see, again, I'm answering the question, still you are not getting. I'm saying depends on what you are trying to do. You cannot say that DS1 is better or DS2 is better. Unless you say that I'm trying to do this, for this operation, DS1 is better. Suppose if I ask you, which are the places that you can go from home? Very easily you can come to this dictionary.
Yeah, 3 places. Directly you can come
Yeah.
in.
You can come to this dictionary and you can count it.
Yeah.
Okay. But you can say, sir, we can do it in DS1 also. We can keep jumping. We can come here. If the source is home, count is 1. Home, here also home, count is 2. Here also home, one thing I left. Home to shop, home to tuition, home to school. One thing I left here. Home to shop, home to school, home to shop, home to school, home to tuition I did not write here. Okay. So one home to tuition also will come here. So count will be 3. So you can count from here also. You can count from here also. We have to traverse all the data. So in this situation, it might be same, but this will be faster because you have to traverse. You have to count only those which are having home. Here you have to count more. But technically, asymptotically, it will be same. But this dictionary storage will be slightly better. Do you guys agree? Is there any other way to store the same data? This type of structure is also called as a graph. So graph is also something that we will learn little bit later. In fact, this representation that I've drawn here, this representation itself is a graph. So for a lot of situations, we have to store data in a graph format. Similarly, we also have many other data structures, which we will see step by step. But what I wanted to show you was that if we have some information, if we have some data, we can store it in different ways. Okay. And depending on what we are trying to do, some data structure might be better than other data structure. How do we choose it? Which is better, which is not better? That is also a topic of discussion. But I hope all of you got some idea of what is a data structure. Is everyone with me so far? Feeling lost? How many of you are feeling lost? Tell me. So if I ask you what is a data structure is a way to store and organize data. What are the different data structures? We have array, we have stack, we have queue, we have linked list, we have trees, graphs, hash tables, priority queue. Many different data structures are there. Okay. The next thing, so data structures we have understood. The next thing is algorithm. Next thing is algorithm. So can we talk about algorithms? So if you remember, I gave you some example. I gave you some question last time of reversing a string. Do you guys remember?
Yes, sir.
Did you guys try that out? Did you guys figure out some other solutions to that question? Other than what we discussed? There is one more question that you could ask me here. That there is something called as a data type in Python. Before we go to algorithm, in Python, when we were learning about Python, I think this question somebody asked me, I don't remember, but there is something called as a data type in Python. And we are learning about data structures. Okay. Is there any similarity? And I think one person was also asking me about list. So list is a data type in Python, and we are trying to learn about data structure. So is there any connection between them? Can someone tell me? Yes or no?
The data structures are fundamental way of storing data, and data type are just using those concepts.
Data type is also fundamental. So when we learned about data types, there also we learned about primitive data types, and then we learned about collections. Correct?
Data type
Primitive
is
data types. What are the data types we learned? We learned there is integer,
string,
string,
float,
boolean, and
boolean, and none.
And collections, what did we learn? We learned about list,
array, not array, list, dictionary,
set,
tuple,
tuple, and string.
String.
String, I told you, string is a fundamental
Immutable.
also. String is a collection also. So when we say data type in Python, and in fact, if you remember the way I taught you list, dictionary, set, and tuple, what did we discuss? We discussed what can we do with a list. What are the operations that we can perform? Correct? Or if you remember object-oriented programming, we talked about characteristics, we talked about behavior. Okay, and I told you that list, dictionary, set, tuple, these are all data types, or we say these are different classes in Python. So when we learn about data type in Python, when we say data type in Python, we are referring to what are the operations that can be performed. For example, if there is a list, we can append in a list, we can extend in a list, we can pop from a list, we can do something from a list. Dictionary, set, tuple, string, float, integer, all of that. If you have integer, you can add one integer to other integer. You can convert a string to integer, integer to float, float to boolean, all these things. So these are about operations that we can do. And data structure, when we talk about data structure, like array, stack, tree, etc., we are talking about how data is stored. So when we learned about list, suppose for example, when we learned about list, we learned about fundamental of a list. Okay, list is one collection of string, integer, float, whatever. And what are the things that we can do on a list? Okay, we can insert in a list, we can find, we can search, we can check membership, we can delete, we can pop, we can extend, we can append, all those things. But when we talk about data structure, we will learn how data is stored in a list on a very fundamental level in terms of computer memory. how actually list is storing that. And when it is storing in a certain way, which operations can be performed on it. That is what we learned when we say it is a data type. Again, it is a very, it's not something that anyone will ever ask you, but in your mind, just keep this clarity that data structures is a universal concept. Data structure is a universal concept. In C also, in Java also, in Python also, in any language, these data structures will be there. It might be available built in, or we will have to implement it from scratch. That is up to us. Okay. And these data types will depend on programming language to programming language. When we talk about dictionary in Python, when we talk about set in Python, tuple in Python, we are referring to what are the operations that we can do on these. Okay, or what is their behavior. But whereas when we talk about data structure, we are talking about how it is actually stored in the memory. So we learned that array is something that is stored in a contiguous way. Linked list is a data structure which is stored in a linked list is something that is stored in a scattered way, where every member points to the address of the next member. Similarly, there can be other data structures also. One more thing I want to talk about, not right now, which we will cover a little bit later, which is called as abstract data type. Okay, so this we will cover a little bit later. Right now, I'm just leaving it. Okay, and we'll talk about algorithms. Guys, all of you are clear till here? We'll take some break, then we'll start.
Yes, sir. So okay, did we cover already abstract data type, right? Already.
Sorry?
Abstract plus we covered already.
We will abstract data type is different thing. It is similar to what we have studied. It's not much, but we'll talk about abstract data type when we talk about once we have discussed array and linked list. When we come to stack, at that point we will discuss about abstract data type, or I'll give you some idea. Right now, I don't want to say too many things. We just want to see high level basics. Then I want to start with arrays. Okay. So just wait for some time. We'll start with algorithms. We'll see a little bit of algorithms and time complexity today. Okay, guys, it's 5:30. We'll take 15 minutes break. Please be back at 5:45. Okay. Or 10 minutes. Be back at 5:40. We'll start at 5:40.
Sir, one question meanwhile. This is
Just
Mustafa.
1 second. Huh?
Okay. So actually, I'm asking, why should we even need to learn all type of data structures if we are going to implement using one particular language, for example, linked list. So if you're using Python for DSA questions, we will not be able to implement linked list, like, because it doesn't even exist.
Why?
How will you make a list refer to another list's address?
You know object-oriented programming.
Yes, sir.
You can invent anything in Python. We have invented a human being. Then why can't we invent a linked list?
But we have to do it from scratch. If it is C++, it will be already present there, right?
I don't know about C++, but even if it is, even if you have to use write it from scratch, it's not something unique that you will do. Whenever you are working, always you will have to implement things from scratch. Not just linked list. Many things you will have to implement from scratch. So if we have to implement it, we will implement it.
Okay.
What is the problem?
So
it's
no
not that you have to
problem
do it every time.
specifically.
Once you have implemented it, then you don't have to do it again. Once you have to do it, you do it and you save it as a class. Then whenever you need, you can invoke that class and you can create instance from that.
I mean, sir, from the interview perspective, I was asking that some of these data structures are very clearly defined in other languages, but in Python, very less of them are directly used. Tree maps and all these are in Java already there. So that was my question.
So if it is there already, so what?
Yeah, I mean, then it would be difficult to do with Python, right?
No.
सर आपने गूगल इंटरव्यू में कौन से लैंग्वेज में डीएसए करा था?
Python.
ओके
Okay.
It's not like that. See, in a coding interview, there is no bias towards any language. If you have to write 10 logical statements, okay, logic, when I'm saying you have to implement a logic in Python, the same logic you have to implement in Java also. Same logic you have to implement in C also. Other than syntax, there is no difference. Please keep that in mind.
Sure.
So if they're asking you a question about linked list, okay, and if they want you to implement a linked list from scratch, then you have to implement it in scratch in C also, you have to implement it in Java also, you have to implement it in Python also. If they want to test something other than linked list, for example, they want to test your knowledge of abstraction, so they will give you a ready-made linked list. So if they are giving you a ready-made linked list, then they will give it to you in all languages. If they want you to implement it, you have to implement it in all languages.
Got it, sir.
So when we learn about C, when you learn about stack and queue, that time you will get to know. We will learn how to create a stack from scratch. We will learn how to create a queue from scratch. So in an interview, they can ask you that implement a queue from scratch. Then we will do that. If they're asking me a question where queue is being used, then we will use some ready-made queue which is there in Python or in C or in Java.
Sir, I do have one question. Can you scroll down? On the data type, you said that primitive collection and data structures, it comes with array, stack, trees, but array is not part of collections.
Array is a data structure. Array is a data structure. Array is a concept of how data is stored. Okay? Based on that, there is list and there is tuple. There is string. So list, tuple, and string, all of these three are flavors of array.
Okay. Okay.
Okay. So not exactly array. The definition that I gave you for array will not sit well with list. So in some other way, list is also an array. That discussion we will have when we discuss about array in detail.
Okay. But
That time I
somewhere
will
in
tell you.
other languages, it's like it's come up in the same series of like list, dictionary, set, tuples, array.
नेमिंग का है ना पाइथन में उन्होंने लिस्ट बोल दिया
समझा?
एरे भी बोल सकते थे
ठीक है.
but in a sense that array is in C, in the same sense it is not an array in Python. List is not an array. List is a type of array in Python.
So even we can implement list using array.
Yes,
If we can say like that.
we can say yes,
Yeah,
absolutely.
It's
If you
in
know array, fundamental array, concept of array,
yeah,
and how memory is stored on hardware and how you are accessing it, if you know that, then you can implement a list in Python. You can write your own list ka definition.
got it.
Just like dictionary. Dictionary is nothing but hash map. So if you know the
Yes.
concept of hash map, you can write a hash map in Python.
Yes.
पहले से जो जिन्होंने लिख दिया उसका नाम है डिक्शनरी, तो उन्होंने अच्छे से लिखा है इसलिए हम लोग उसको यूज करते हैं. आप चाहो तो आप खुद से भी लिख सकते हो.
Got it. And even extra function that we can use over the list or set tuple whatsoever they have defined.
They have defined some abstraction which we are using. If you want, you can write your own.
Yes.
If you want to implement a list using linked list, that also you can do. So
Yes.
all these things we will see.
Okay.
All these things we are going to see when we learn about, say for example, queue. We will learn how to create our own queue. So we know about queue, so we can create a queue using list also. We can create a queue using linked list also. We can create a queue using a stack also.
Got it.
So we will learn, and there only the concept of abstract data type will also come.
Got it.
So the data type is part of the data structure, sir?
Data type is?
Part of the data structure. Is a subsection of the data structure. For example, let us say in the data structure, right, array is a concept, but in data type also list, tuple, set, everything is part of array, right?
part of array. It uses array. It uses underlying concept is array.
Underlying concept, yes,
Huh.
correct. Yeah. It's not the underlying concept of array data structure like this, what can say.
Sorry?
No, it is list tuple and set, it is underlying data structure of array. Yeah.
They are types of array. They are based on array data structure.
Array data structure, okay.
Correct. ले लीजिए. Hmm. 005 302 302. Okay, guys, we'll start. All of you are back. We'll start at 5:45. 4 more minutes. Okay, wait. Okay, guys, we'll resume the session. We're talking about algorithms. So I gave you a definition of algorithm, guys. Is everyone back? Please write it in the chat. Okay. So algorithm, I told you that it is a, what is algorithm? Again, I don't want to give you a very bookish definition, but it comprises of all the operations we can do on data structure to solve a well-defined problem. Okay. So in finite number of steps. And I told you that these steps should be unambiguous. Again, these things are usually taken for granted, that steps will be unambiguous and steps will be finite and should give correct result for all valid inputs. Okay? So this is a very hygiene kind of a thing for algorithm, that at least these conditions should be met. Again, we don't want to get too much into the definition, although it is fairly intuitive, it is commonsensical, that you will be able to understand it. But let us take an example of what might be an algorithm. Okay. So we can take example. I think you already know the algorithms, because in the last session we had some discussion around reversing a string, or finding sum of consecutive numbers and other things. Okay. So let us talk about some algorithm. Okay. We'll take one example. Let us take one example, and we'll take example related to array only. Okay. So let me give you an example or a question that find if there is a duplicate number in a given array. Okay. Suppose you have given a number called nums, and there are some numbers here, maybe 10, 15, 18, 12, 16, 14, and maybe 15 and 12. Suppose this is the question that is given to you. So can you tell me what should be the approach to solve the problem, or what could be an algorithm? I told you that what is algorithm? It is operations that we can do on a data structure to solve a well-defined problem. So problem is well-defined, that you will be given an array of numbers, and in those array of numbers, we have to tell whether there is a duplicate number or not. So obviously we have to return a true or a false. Correct? We have to return a true or a false, whether there is a duplicate or there is no duplicate. Or I might ask you to return which is a duplicate number. So in this question, there is a duplicate number which is 15. Correct? So 15 here is a duplicate number. So I can ask you to return the duplicate number, or just whether the duplicate number exists or not. So that clarification you can ask in the question. Suppose I'm telling you that return a Boolean, which means you have to return a true or a false. Is the question clear, guys? Can you give me can you help me solve the problem? What might be some series of steps that I can follow to solve the question? 12 is also a duplicate here by mistake. Correct. So what is the answer for this question? First of all, the answer is true. How can we arrive at that? Can someone help me? Anubhav is saying next number should not be previous. Dhruv is saying for loop and if conditions. That is not a logic. For loop and if condition is not a logic. Create empty variable and store all and check. Compare n with n plus 1 values. Count the occurrence of each number in the list, and if the count is more than 1, return true or false. Correct?
Take each value and find out is there any duplicate. Means you need to see all the values, compare each values.
give me step by step. You see, what is the condition for algorithm? It should not be ambiguous. So tell me what I should do step by step. What I should do? How should I start?
So firstly, we have to store first element, and we have to check other element. Is it available or not? And
Store where?
subsequently, in the list.
Wait. You are saying first we have to store a number somewhere. Where to store that?
First one. That is
First number
10.
is 10.
Yes, sir.
I will store it where?
Store in some any other variable.
Temp. Okay, temp is equal to 10. After that?
Yes, sir. After that, we should compare with others.
Others, which others? Like 15?
15, 18,
12,
16
and other.
Okay, correct.
And after that, if it is available, then we have to return true.
Okay, otherwise?
And otherwise false.
That's all.
Yes, sir. No.
Next we change
After
the temp
Wait,
value
let
to
him
15.
finish. Let him finish. Yes, after that. Suppose I took 10. So 10 I am comparing with 15, then 18, then 12, then 16, then 15, then 12. It is
Yes,
not
sir.
same. After that?
After that, if the condition is coming false, then we have to we will override this temp with the other with the next element, like 15.
With the next element, correct.
Yes,
So
sir.
we'll take 10. So the logic, the algorithm now that he is telling me is that we will take 10, okay, and we'll compare 10 with all the other elements. We'll compare with 15, 18, 12, 16, 15, and 12. If we find false, if we find the number to be same, then we will return true and end the condition. If it is a false, if all of them are false, then we will go to 15. Again, we'll compare 15 with 18, 12, 16, 15, 12. After that, we'll go to 18. After that, we'll go to 12. Then we'll go to 16. Then we'll go to 15. And then we'll go to 12. If we have never found anything to be equal, then we will return true. Otherwise, we'll return. If we have found something, then we will return true. That is the logic.
Yes,
It's an algorithm, good algorithm.
Yes, sir.
Correct. So how can we write the logic?
So firstly, the temporary variable temp is storing the first element. After that,
We can say for
yes, sir.
I in
nums
range length of nums. Correct. We'll say temp.
Yes.
You're saying temp variable is equal to nums of I. Correct.
Yes, sir.
Okay. And then we'll say for j in
nums.
Range what? Length of nums.
No. I think here
Sir,
we
I plus
mention nums,
one.
sir.
This one. Length of
I plus 1 to then colon.
I plus 1 to
Just colon.
length of nums. Correct. Colon नहीं होगा ना, indexing नहीं कर रहे ना. You have to give start and end. And you have to compare
temp with each element of the.
You have to compare if temp is equal to nums of j, then we'll return true. Guys, are you understanding what I'm doing?
Yeah.
If all this is done and nothing has happened, then we will return false. Does this make sense?
Fine, sir.
So there can be another way.
Can be many ways. But is this an algorithm? Someone gave one more solution. So can we try it out in Python? Okay, we'll try it out in Python. But I want to see there can be one more way. Someone gave me that sort it and compare the next value with the current value. Okay, so this is, we can say this is algorithm 1. Okay, this is good. Okay, someone has given me another solution. I want to try that also. So one, she's saying that count the occurrence of Okay, Vansh is also given one solution and Sai Krishna has given one solution, that we can sort it and then compare with next value with current value using for loop. Okay, so if I'm having nums, first he's saying that I want to do sorted nums. So first I will create sorted nums. Guys, are you following what I'm doing here?
Yes, sir.
So he's saying that first I should sort it. Fine, I will sort it. So the first value will be 10, then I will get 12, then again I will get 12. After 12 I will get 15, again I will get 15, and then I will get 18. Correct? This is the sorted one. 1 2 3 4 5 6 7 1 2 3 4 5 6 एक और एलिमेंट मिस हो गया. 10 12 12
16, sir.
15. After the 15 there is 16. Then we have 18. So he's saying the first we will sort it. Okay, so how will we sort it? Sorted nums I have written like this, but it will actually not be like this. We will do इसको comments में डाल देते. This will be sorted. We are writing code in Python. Okay, so this will be sorted nums. And then what he's saying that we can compare every value with the next value. So 10 we can compare with 12, 12 we can compare with 12, and 12 and 12 are same. So we will get the duplicate number. Correct? So Sai Krishna, can you give me the logic? How will we do it? For I in range of length of nums.
सर यहाँ पे पाइथन यूज कर रहे हैं तो आई इन सॉर्टेड नम्स भी तो कर सकते हैं ना, ये रेंज
सॉर्टेड नम्स भी कर लो. हाँ,
ठीक है.
कर सकते हैं. नहीं, सॉर्टेड नम्स करोगे तो नहीं होगा. Sorted, because this is giving you just the range, no? So you do nums or sorted nums, so value you will get same. This is basically saying length of 1 2 3 6. This is basically saying 6, range 6. Sorted भी करोगे तो वही आएगा ना. पहले तो सॉर्ट करके इसको स्टोर करना पड़ेगा ना.
मतलब रेंज फंक्शन ही यूज ना करें तो आई इन सॉर्टेड नम्स बस.
I in sorted nums, if you do, then how will you find the next value?
वो तो आई को इंक्रीमेंट करते जाएंगे तो नेक्स्ट वैल्यू आता जाएगा.
कैसे नेक्स्ट वैल्यू आएगा? If you know 12, how will you, if you know 12 here, how will you go to 15? You have to know the index of 12, then only you will go to 15, no? If you know the value, then how will you go to the next value? Are you getting what I'm saying?
Sir, actually no, sir.
You try, wait, okay. First, let me write this.
Okay.
So if you are saying I in range of nums, then what will I compare? Should it be I in range of length of nums or -1 here? क्या होना चाहिए? If nums of I is equal to nums of I plus 1. Okay, then what will I do? I will return true, else I will return false. Is this correct? I'm not claiming it to be correct. You guys tell me. What will happen here? More than whether it is correct or not, is this an algorithm? It is an algorithm. What Sai Krishna is saying is correct because he is giving me a set of steps, and the set of steps is quite clear what I'm supposed to do. First, I will sort it. Then I will start with the first value, and I will compare it with the next value. Then I will go 12. I'll compare 12 to 12. Then I'll go to 12. I'll compare 12 to 15. Then I'll go to 15. I'll compare 15 to 15. Okay, if there are no duplicate values, I will never get true. So I will return false. Anyone is having any problem?
Sir, it's more about the conditions. Like in first one, we use extra space. If you give us more condition, the steps will be changed.
What do you mean step will change?
Do we need to use extra space or not? Or let's say we have more than one duplicate, because in both of the case, if we got one duplicate, it will be stopped. But if we have more than 2 duplicate, let's say,
Okay.
But question is,
we have to give all the values, the steps will be changed with respect to the condition you will provide us, right?
But
Extra
the
space
question is that we're not finding out whether to find the duplicate or not. It's not how many number of how many we have duplicate. It's whether you have one duplicate, it's sufficient, right?
Question is find if there is a duplicate number in the given array. And here I have have to return bool, means true or false. Duplicate है कि नहीं है? एक duplicate है, दो duplicate है या 10 duplicate है, वो तो question नहीं है.
It's a valid one. We can easy one compared to older one. Less iteration. Only thing is that we are sorting and then we are comparing.
You are correct. But on what basis you are saying that algorithm 2 is easier or better than algorithm 1?
Sir, one more way can be there if we can use sets.
Fine. There can be many ways. I will
check the length. Right?
Please write down your thought in the chat. Then I will write the code for that. So one more person has given me the solution. Who is that person? Vansh. So Vansh has given me a very good solution here. That is, let me write it algorithm 3. So I'm showing you there can be different number of algorithms that can solve the same problem. So Vansh is saying that we will count the occurrence of each number in the list, and if count is more than 1 for any number, then we will return true or false. Fine. So this is the nums that have been given to us. Then we will also learn how to evaluate. If we are solving this problem, then we will learn about algorithms. Okay. With one problem only, or we'll do one more problem. So this is also a lead code problem. Okay. So after today's class, you can go on lead code and solve this problem. Okay. So what Vansh is saying that, sir, we can count. So we can create what Vansh is saying, what I have understood. Once you tell me if I've understood correctly. He's saying that we take 10. Okay. So we'll create one dictionary and we'll say that 10 has come one time. Then we'll go to 15 and we'll say 15 has also come one time. Then we'll go to 18. We'll say 18 has also come one time. Then we'll go to 12. We'll say 12 has come one time. Then we'll go to 16. We'll say 16 has come one time. Then we'll go to 15 and we'll say 15 is already there. So we'll do 1 plus 1. So it will become 2. So the moment it becomes 2, we know that there is a duplicate. Is this a fair solution?
No.
No, why?
Because we are not sure how many elements do we have, right? Where is exactly duplicates?
So this might require more iterations because
more iteration,
each
many,
number
many
more
number of
iterations, less iterations, that we will discuss later. Is this a solution or not? I'm not saying it is a good solution or not. Is this work? Will this work or not?
Yes.
It works. It works, but if we have more number of elements, we should not find it out where is the duplicates that. Right, we need to access all the values. Then only if there is duplicates, then only it can be counted as 2.
I did not understand.
No, for example, if it is just 10 elements, if we have those elements over there, my duplicates elements are presented at the 1998 position something, no?
Okay.
By the time, and how is efficient with this approach?
How
it is efficient, this approach? For example, line 15 is a number, right? We have the overall.
Fine. You are saying that here we are having only 6 elements, 7 elements, but if we are having 7,000 elements,
yes,
and if the
correct.
duplicate is at 6,999 position,
yes,
then we have to go
correct.
through all the 7,000 elements to find the duplicate, correct?
Yes, correct.
Fine. So is that not the problem here also?
Yeah, that is also the similar.
Is that not a problem here also? Your line of thinking is correct. You're thinking that whatever I'm writing, if the input size becomes very, very big, then what will happen? That is the correct line of thinking. We will talk about that in detail. But whatever problem you have pointed out, the same problem is there for algorithm 1 also, 2 also, 3 also. In fact, algorithm 3 is the most efficient till now, whatever we have written. I will tell you why. But before that, okay, this we will call it as a frequency dictionary. will this solution work or not? Is this first of all an algorithm or not? Do you guys agree?
Yes, for
Correct. So can we write the code for this?
I in
First of all, we'll create a dictionary.
dictionary. Yes, empty dictionary. No,
We'll say that we'll create a frequency dictionary. This will be empty dictionary.
empty dictionary.
And we'll say for
key
num
value.
in nums.
Yes.
Now we can write num in nums. Whoever was
Okay.
asking me in the previous question, you can see that here we can use it, here we cannot use it, because here we have to do I is equal to I plus 1. अगला नंबर पाने के लिए आपको इंडेक्स चाहिए, लेकिन यहाँ पे हमें अगला नंबर से मतलब नहीं है, तो हम लोग नम इन नम्स लिख सकते हैं. रेंज आई फॉर आई इन रेंज ऑफ लेंथ ऑफ नम्स भी लिख सकते हैं. Okay, so if we write it like this, then we can say that if we do this, then we can say that frequency dict
dot square bracket of num
dot get
yeah.
num, and we'll say 0 plus 1. Can we write it like this?
Yes.
And can we say this to be
Yes, we
frequency
can
dict of num is equal to?
Yeah.
And can we write it in a better way? Can we say that if num in frequency dict, then we will return true.
Yes.
Else
Yeah.
Are you guys understanding what I'm doing?
Yes.
Else. Actually, this thing is not needed here. Else. We can do this. And then what we can do? We can return false. 3 solutions we have given. Some people are writing that length of list is not equal to length of set of list. That is the same approach as algorithm 3. You can do that also. Did you guys understand the 3 solutions? Is there anyone who did not understand, or is there anyone who has some other solution?
Do we follow the can we compare front and back at a time, sir?
Front and back means?
Ith iteration or last iteration at a time. 2-pointer approach.
How? How will that work? Viera is asking how last was more efficient. We'll discuss about that. We'll talk about time complexity now. So then we will discuss it.
I think forward we can movement one position.
What you are saying, I don't know who is talking, but I think what you're trying to say is 2-pointer approach. You are saying the same concept that we learned in reversing a string. I think that's what you are trying to
reversing string, yes.
That we will have this 10, 15, 18, 12, 16, 15 and 12. You are saying we'll put 1 pointer here and 1 pointer here, and we'll compare 16 and 12.
Yes.
After that, what you will do? If they are equal, if they are same, then you will say false. If they are not same, then what you will do?
Which one you will forward? No? We can forward that.
Which one you will move forward?
Oh, okay.
You will move this one forward.
Yeah.
Or you will move this one forward.
Yeah,
You will move
yeah,
this
sure.
one like this, or you will move this one like this.
Correct.
You cannot
We
move
can
both.
sort. We can move both here. We can move both, but we can sort it out, right?
If
Sort
you
it
sort
and
it, then why it is needed?
no need. Yeah, no need. Yes, correct. You're right.
So you have to think in
Yeah.
your mind. You have to take one example. Whatever idea you are getting, your line of thinking is correct.
For this use case, I think is not go with this.
But how do you
Yeah,
check?
this.
How do you check? You have to do a dry run. In last class also I told you a dry run. That fine. If in my mind, if I'm doubting that two-pointer approach can be used, then fine, I will do like this. I will see that which one to it is. If both are equal, then fine, it is duplicate is there. But if they are not equal, then I cannot move them because this and this can be equal, or
No.
this and this can be equal. Maybe the second element can be equal to the last element, or second last element can be equal to the first element. So I don't know which one to move. So that idea will not work.
Yeah, correct.
Okay. Now let us talk about the time complexity or efficiency. Okay. So when we talk about time complexity or efficiency, let us come here and let us talk about time complexity and efficiency. Memory and low level architecture we'll talk about when we start array. Okay. Today let us not discuss it. Today let us only talk about algorithms and time complexity. Okay. So in time complexity, what we do, what is a way how to evaluate an algorithm? Okay, many people are asking me many times in WhatsApp messages also. Sometimes you guys will write it in chat also many times, that even in the first discussion that I was having, many people were asking that, sir, we should write code in Java. Java is fast. That code will run in 5 seconds. Python code will run in 10 seconds. C code will run in 2 seconds. So therefore, we should learn C, we should learn Java. Your question I'm going to answer today. Okay. So how do we evaluate an algorithm? When we have written the algorithm, we have written 3 algorithms here. We have algorithm 1, 2, and 3. And my question is that which one is better? Okay, which one is better? So how will we decide which one is better? Can someone tell me? What is the way to define? What is the way to find out?
I think the line of code must be lesser than other codes.
Line of code is lesser than other codes. Okay. It is possible that you line one line of code that is very inefficient, and you write 100 lines of code that is much, much efficient. Line of code definitely.
For CPU usage.
CPU usage, very good.
Space
And time of
complexity and
execution.
time complexity.
And time of
CPU usage or
time of
memory
execution.
usage.
Time taken for execution.
For execution.
Yes.
Okay, what else? Good.
Memory usage.
So if the algorithm takes more time for execution, then it is not very good. If it is taking less time, then it is very good. Maybe we can say that.
Yeah, but sir, time also depends on other factors other than our code.
Correct.
Sir, how a time grows with grow in input.
How time grows with growth of input.
Yes, we can say like.
What does it mean?
It means
समझाइए
like
थोड़ा सा.
जैसे कि मान लीजिए कि
For example, the rate of
बताने दो उसको, जो बता रहा था उसको बताने दो.
okay.
लेट्स सपोज एन एग्जांपल कि हमारे पास मतलब 100 सीढ़ी है चढ़ने के लिए. 11 एग्जांपल में कि 100 सीढ़ी है चढ़ने के लिए. 100 सीढ़ी चढ़ने में हमें 5 सेकंड लग रहे हैं. ठीक है, तो उसके हिसाब से अगर मतलब 1000 सीढ़ी हैं, ठीक है, 1000 स्टेयर्स हैं, तो उसके हिसाब से
if you are having 100 steps, it is taking you 10 seconds.
हाँ,
if you are
तो
having
अगर
1000 steps,
then it will be, let's suppose ये अगर 100 सेकंड से कम 50 सेकंड्स लेता है, तो उसको